Welcome to Eureka Math. I'm Mr. Shankel. I'm going to be helping you today with Module 4, Lesson 7. Let's get started. All right, we're just for the first three going to solve each of the following equations for x. So a little review. We're just trying to isolate the x. So right away I see I've got x's on both sides of the equal sign. So I'm going to move them. So 7x minus 5x is 2x minus 3 is equal to 5. And then I can go about isolating my variable by adding 3 to both sides. That gives me 2x equals 8, and then multiply by reciprocal, balance the equation, and we get x equals 8 divided by 2, which is 4. So for the first equation, we have x equals 4. One solution. Number 2. Same thing. Okay, so this time I see, let's see, I've got, do you see a problem already? I'm going to try to get all my variables on one side, but look what happens. The 7x's cancel here. I'm left with 5 equals the 7x's cancel here, and I'm left with negative 3, and negative 3 does not equal 5. So this means that there are no solutions. There are no solutions. And notice that when we look at the original equation, we could see that the coefficient with our variable was the same, and we see that the constants are different. So if the coefficients of the variables are the same, they're gonna cancel each other out, and then we're going to be left with the constants. And if these two are not the same, then there's no solution. So there's no solution for x because negative 3 does not equal 5. Okay, let's try number 3. Okay, so look, same thing's going to happen, right? We're going to take 7x away from here. We're going to take 7x away from here. And those cancel. I get negative 3 equals, this 7x goes away, negative 3. Negative 3 equals negative 3 is absolutely true. It's always true. So what this means is there are infinitely many solutions. It doesn't matter what I put in for x. The two sides are going to be the same. They're equal. So they're the same thing. And we can see that if we look before we did any work. Look at my coefficient is 7, coefficient 7. Constants negative 3, constants negative 3. If everything's the same, then there's going to be infinitely many solutions. And just to give you an example, what if I said, what if x is 5? Well, if x equals 5, I would get 7 times 5 minus 3 is equal to negative 3 plus 7 times 5. And then 35, 7 times 5 is 35, minus 3 is 32, is equal to 7 times 5 is 35, and 35 and a negative 3 is 32. I'm always going to get, no matter what I put in for x, the two sides are going to be equal to each other. All right, so let's go back to the first one that we did, and look, coefficient was 7, coefficient 5, so I have different coefficients, and my constants are also different. So I know I'm going to get one solution here because the coefficients were different, the constants were different. I should be able to look at equations in this form and be able to decide if I'm going to have one solution, no solutions, or infinitely many. So look at the second one. Coefficients are the same. That's not good. So it's at least going to be no solution. And how do I figure that out? Well, I look at the constants. And if those constants are different, then I'm going to have no solution. And then finally, for number 3, we recognized that everything was the same. The coefficient's the same, the constant's the same. And if that's the case, then basically we have two sides that are exactly the same on our equation, and they're going to be infinitely many solutions. Doesn't matter what I put in for x. They're always going to equal each other. All right, so let's see if we can recognize that from some equations before we actually simplify and solve for x. So first I'm going to combine like terms here. So I'm going to put this 11x and the negative 2x together. So I'm going to simplify this a little bit. 11 minus 2 is 9x plus 15. That's on the left side. On the right side, I can put constants together, so I get 9x plus 15. So 9x plus 15 equals 9x plus 15. Well, right away I see that they're exactly the same, right? The coefficients are the same. The constants are the same. This is going to give me infinitely many. So this is going to be infinite solutions, infinitely many solutions. Doesn't matter what I would put in there. I could put a 1 in and the two sides would be equal to each other. I could put a 10 in, the two sides would be equal. It really doesn't matter what I choose. The two sides are going to be equal because they're exactly the same. Same constants, same coefficients. All right, number 5. Let's simplify. Let's distribute this. We get 3x minus 3 times 14 is 42. And then plus 1, and that's equal to negative 4x plus 5. And then let's see, I can do a little more. I can go 3x minus 42 plus 1 is a negative 41 is equal to negative 4x plus 5. And then look, yeah, we've got a coefficient of 3, a coefficient of negative 4. My coefficients are different. My constants are also different. This is going to be one solution. I can actually solve this and get one solution. Let's find out what it is. Add 4x, get my variables all on the same side. That gives me 7x minus 41 is equal to 5. Add 41, and we get 7x equals 46. And then multiply by reciprocal, and that leaves us x equals 46/7 is my answer. That's the one value of x that will make that equation true, and we recognize that right away because our coefficients were different and our constants were different. Number 6, all right, let's simplify so we can get them in the same form. I've got a negative 3x and a negative 7x is a negative 10x plus 32 is equal to, if I use the distributive property here, this is a negative 10x plus negative 2, that's going to be a negative 20, negative 20. And then let's look, I've got the same coefficient. That means they're going to go away, and I'm going to be left with these two are equal to each other, and they're not. So, so this is no solution. There is no solution. I don't need to go any farther because I'm just going to end up getting 32 equals negative 20, and that's not true. So that's it. All right, number 7. Simplifying again, half of 8x would be 4x, and half of 26 would be 13. On the other side, I have 13 plus 4x. Well, look, I've got the coefficient of x is both 4, and the constant is 13 on both sides. So these two sides are exactly the same. They're equal to each other. So this is going to be infinitely many solutions. I could put anything in for x, and it will be equal. So infinitely many is my answer. Infinitely many solutions. All right? And that is your lesson 7. I hope that helps. See you again next time.